Hi, we are from Group 3 of P02. Today, our topic is on ELNFAS Boeing 747 and we are going to present to you with this PowerPoint presentation. Q&A will be at the end of the presentation, and these are our group members that will be presenting with me. And here are the contents that we will be presenting you with. Now I will be talking about the purposes and functions of an ELNFAS. ELNFAS is known as Engine Indicating and Crew Alerting System. The purpose of an ELNFAS is to provide flight crew with engine and other systems instrumentation data and crew annunciations. And also, it provides routing and data acquisition to the crew for aid in flight. Here are two pictures of ELNFAS display, the upper and the lower display. They display navigation data and orientation displays. Next, I will be talking about the functions of ELNFAS. ELNFAS includes two color cathode ray tubes or CRTs, two computers and a control panel, one on the right computer and one on the left. These two computers are determined by a computer selector. When in auto, it is signaled to use the left computer. When control switches to the right, when the left computer fails. Left or right computer, it can control the CRTs depending on which position. L controls the left computer while R controls the right computer. Next, I'll pass on to Lian Eng to continue about ELNFAS.
And now I'm going to talk about the warning, alert, and advisory and caution message. In the primary display, it will show engine pressure ratio or EGT and exhaust gas temperature. The secondary display will display things such as engine status, parameters, and maintenance informations. There will be four types of warning messages displayed on the primary ELNFAS display. Level A, Level B, Level C, and Level D. Level A will be displayed in red, B will display in amber, C will be displayed in cyan, and D will be displayed in white. And in compact mode, when the primary display engine parameter will be displayed normally, the secondary engine parameter will be displayed in digital readout, and in the secondary engine parameter has exceeded, the digital readout will be displayed in red or amber. In the flight deck, there are the warning and caution annunciator. In the case of level A warning, the warning annunciator will light up and give a aura sound. In the case of level B warning, the caution annunciator will light up and in amber and give a aura sound. There is a switch located in the glass shield to off the light and aura indication of the annunciator, but the warning messages will still be displayed in the primary ELNFAS display. There are several oral warning indications that the ELNFAS will give out, such as single chime indicating a caution tone, a triple chime indicating a warning tone, a horn indicating that the gears are not down, and a fire bell indicating there's a fire warning. This is an example of the warning messages that will be displayed in the ELNFAS. And next, I will pass on to Jian.
And now I'll be talking about display format or modes. ELNFAS shows information about the aircraft system, including its fuel, electrical and propulsion systems. ELNFAS displays are often designed to follow traditional round gauges while also supplying digital readouts of the parameters. ELNFAS improves situation awareness by allowing the aircrew to see complex information in a graphical format. and by also informing the crew to weird or hazardous situation. For example, if an engine begins to drop in oil pressure, the ECAS might begin to sound an alert, switch the display to a page with the oil system information, and outline the low oil pressure data via a red box. Extra care must be taken when designing ECAS to ensure that the aircrew are always provided with the most crucial information and not overloaded with warning or alarm. ECAS mainly includes instrumentation of various engine parameters, including revolutions per minute, temperature values, fuel flow and quantity, oil pressure, etc. ECAS is an important function of a glass cockpit system, which replaces all analog gauges by software-driven electronic displays. Most of the display area is used for navigation and orientation displays, but one display or a section of a display is set aside specifically for ECAS. The crew alerting system is used in a place of the panel of older systems. Rather than informing a system failure by turning on a light behind a translucent button, failures are shown as a list of messages in a small window near other indications of the ECAS. And now I would like to pass on to Gideon.
And now I'd like to introduce to you the ECAS control panel. Basically, there are different switches and buttons on the ECAS panel. And firstly, the display select switch. It will choose associate system displayed on ECAS cathode tube. Followed by the EPS switch, it will show electronic propulsion control system maintenance messages for each respective engine. Now the test button. It will test the test of all ECAS display and function when being pushed. When it's being pushed for a second time, the cathode tube reverts to secondary engine mode. Now the event read buttons. It will cause the lower ECAS cathode tube to display data that was recorded previously for system select with display select switches. And now I would like to talk about under the event read button, there's a auto button and a manual button. The auto button display data recorded automatically by ECAS, while the manual button display data recorded manually by use of the record button or by use of event record button on pilot's ECAS control panel. The record button is the data that is currently displayed on the lower ECAS control cathode tube as selected with the display select switches that will be recorded in the ECAS memories. For the erase button, when the button is held for 3 seconds, it will erase data previously recorded automatically or manually in ECAS non-volatile memory. And now I'd like to talk about ECAS system testing. The test of ECAS is initiated with the ECAS test switch. The test can only be displayed on the ground with the parking brake set. When the test switch is pushed, a beeper and siren will sound and the master and warning caution light will be illuminated. The test patterns will appear on both cathode tubes and the standby engine indicator will come on. A configuration warning will also occur. The test in progress message will appear during the test and disappear when the test is complete. A test OK message will then appear if the test is passed. However, if a test fail message appears, means the fault will be detected, and pushing the test switch once more cancel the test and return the display to the engine indicating mode. And now I'd like to pass on to Jingzhen to carry on with the rest of the presentation.
Now I'd like to talk about ECAM. ECAM stands for Electronic Centralized Aircraft Monitor, and ECAM is similar to ECAS, and it displays data concerning aircraft system and failures. And it is developed by Airbus. It displays corrective action to be taken by the pilot as well as system limitation after the failures. ECAM is to display information to the pilot in a quick and effective manner. Sensors in the aircraft like monitoring key parameters. It feeds their data into two SDAC. SDAC will then process the data and feed it to two flight warning computer, which is the FWC. FWC check for discrepancy in the data and then display the data on the ECAM displays. There is a difference between ECAM and ECAS. ECAM is developed by Airbus and it provides the features of ECAS but also display corrective action to be taken by the pilot. and as well as system limitation after the failure. But for ECAS, engine indicating and crew alerting system is used by Boeing and others. It displays data concerning aircraft system and also failure. Have engine instruments, warning, caution, and alert messages and status messages.
We have come to our video presentation. Thank you.